Haskell's type system is much easier to understand once you realize that types are sets of values and type classes are sets of types. For example, the type integer includes values like 3 and 8. The type class num includes the types integer and double. This is somewhat analogous to Java, where classes are sets of objects and interfaces are sets of classes. For example, the interface comparable includes the classes string and integer. We can use :type or :t to find out the type of a value. The result says that true is a bool. A is a char. That's a list of chars. Have you noticed that type names start with uppercase letters? So do type class names. Something strange happens if we ask for the type of 3. This says there is some type A in the type class num. 3 is of type A. A is called a type variable. The value 3 actually belongs to every type in the num type class, including integer and double. Haskell is being lazy and not committing to a specific type. If we bind the value to a name, Haskell has to commit to a type. We can also force Haskell to commit by using an explicit type annotation. Functions also have types. This says, for any type A, head takes a list of A's and returns an A. We can also ask about the type of the plus operator. Since plus is an infix operator, we have to surround it with parentheses here. This says there is some type A in the type class num. Plus takes 2 A's and returns another A. How about zip? Zip takes a list of A's and a list of B's. It returns a list of A-B pairs. Haskell's type inference is startlingly effective. For example, consider this function. This is a fairly silly function that adds the first element of a list to the length of that list. Haskell figures out that since length returns an int, the overall result must be an int. We are allowed to specify the type of a function along with its definition. This can be a good idea since it provides some documentation for us and anyone who has to read our code. It can also help us find bugs. Consider this function. This is supposed to tell us if x evenly divides y. For example, let x be 2 and y be 5. 5 divided by 2 is 2, but 2 times 2 is 4 and not 5, so 2 does not evenly divide 5. Let's try it. What happened? In Haskell, 5 divided by 2 is not 2, but 2.5. One way to address this problem is to specify that we expect x and y to be ints. Unfortunately, we now get an error when we try to load this function. The error message probably still seems a bit cryptic. The first line says that the type int is not a member of the type class fractional. The slash operator only works on fractionals. It turns out the operator we want is div. By specifying the type of our function, we were able to find a bug that we might have otherwise missed. This sort of thing is so common that it's become a running joke among Haskell programmers. If you can get your code past the type system, it's probably correct. If you haven't done so, be sure to read the chapter in the book. You'll learn about many specific types and type classes, as well as the difference between int, integer, and integral.